Often students imagine organic chemistry as a battlefield. Let us consider the same thing. On one side, you have electron hungry warriors, and on the other side, the electron rich attackers. Today, you will finally meet the heroes of most of the chemical reactions, nothing but electrophiles and nucleophiles. And trust me, once you get them, half of the organic chemistry becomes easy for you. Hi, I'm Dr. N. Swati. Let's dive deep into today's topic, the reaction warriors, electrophiles and nucleophiles. So what are electrophiles? Electro means electron, phile means love or affinity. That means electrophiles are nothing but electron lovers. Let us try to understand this term at much deeper level by considering atomic structure. So inside every atom, it consists of a nucleus where it holds protons, which are positively charged ones, and neutrons, which are charge-wise neutral. Surrounding by each nucleus, the atom consists of different energy levels where the negatively charged electrons will be roaming. So the number of energy levels in an atom, it depends on the atomic number. Now, as I mentioned earlier, electrophiles are nothing but electron lovers. That means they have affinity towards the negatively charged electrons. It means they are electron deficient species. That is why they have affinity towards the electron rich species like electrons. Now let us understand the types of electrophiles. There are three types of electrophiles are there, and the first type are known as positively charged electrophiles. Because electrophiles are electron deficient, some of the electrophiles they possess completely positive charge. And the examples includes proton, bromonium ion and nitronium ion. So in case of proton, this proton will be formed after removal of one of the electron present in the hydrogen atom. So hydrogen atom, as you know, that it consists of an electron. Now if you remove this electron from the hydrogen, it becomes proton, which is an example for electrophile. Similarly, in case of bromonium ion will be formed from bromine molecule. So bromine molecule, it consists of two bromine atoms. When the bond present in bromine molecule undergo heterolysis, that means the bonded pair will be moved towards any one of the bromine atom. Then it generates two types of the ions. Bromine atom, which is getting the electron pair, becomes electron rich, so it will form Br minus ion, and which is known as bromide ion. On the other hand, the other bromine, it will become electron deficient. So that will form Br plus ion, which is nothing but the bromonium ion. So this is how by the heterolysis of bromine molecule we get bromonium ion, which is an example for electrophile. Now the other example for the electrophile, positively charged electrophile, is nitronium ion, which is denoted with NO2 plus ion. So these are the examples for positively charged electrophiles. The second type of electrophiles are known as partially positive electrophiles. So here these electrophiles are formed due to bond polarity. Particularly the molecules which are having polar bonds will be creating this type of electrophiles. For example, carbonyl carbon, that means carbonyl compounds like aldehydes, ketones, esters, ceramides, they will be having carbonyl group in them. And usually this carbonyl group is electron deficient. It is only because the bond between carbon and oxygen is a polar bond, because this particular double bond is shared between two atoms which have differences in their electronegativity. So out of carbon and oxygen, the electronegativity of oxygen is more. So that is the reason the bonded pair will be more moved or attracted by oxygen. So because of that reason, oxygen gets partial negative charge and the carbon becomes electron deficient, due to which carbon gets partial positive charge. So that is the reason always carbonyl carbon is electrophilic in nature, because it is electron deficient. The other example is the carbon halogen bond, which is present in alkyl halides. So let us try to understand this bond polarity with an example, that is methyl chloride. So in case of methyl chloride, it consists of carbon chlorine polar bond. So why this bond is known as polar bond? It is because of the formation of the dipoles across the bond, because this particular bond is shared between two different atoms, that is the atoms which have differences in their electronegativity. So chlorine is more electronegative when compared with carbon. So that is the reason this bonded pair of electrons will be more moved towards chlorine or more attracted towards chlorine. So hence the chlorine gets the partial negative charge, while the carbon, because the pair of electron is moving towards chlorine, it becomes electron deficient. That is the reason the carbon which is holding the halogen, it becomes electron deficient, hence it gets partial positive charge. So the carbonyl carbon in case of carbonyl compounds and the carbon holding the halogen in case of alkyl halides. These are the examples for the partially positive electrophiles. Now the third type of electrophiles are known as neutral electrophiles. That means these compounds or groups, they do not possess formally any charge, but due to the electron deficiency in them, due to incomplete octet configuration, they are considered as electrophiles. Hence, they are known as neutral electrophiles. Let us consider example under this particular class, that is boron trifluoride. So in case of boron trifluoride, the central atom is boron, which is bonded with the 3 fluorines via a pair of electrons. So all over, if you see, across the central atom bromine, there are 6 electrons are available. 3 bonds means each bond will be utilizing 2 electrons in its bond formation. So overall 6 electrons will be there surrounded by each boron. Now to get the stable configuration, octet configuration, the boron is deficient of 2 electrons. So that is how boron is considered as electron deficient atom in case of boron trifluoride, and that is how it is an example for neutral electrophile. In case of aluminum trichloride also, aluminum is the central atom which is attached to 3 chlorines by utilizing a pair of electrons with respect to each chlorine. So that is how the overall number of electrons surrounded by aluminum becomes only 6 electrons, and this aluminum central atom is also deficient of 2 electrons to meet with the octet configuration, that is to achieve the stable configuration. So that is the reason even the central atom aluminum is electron deficient. So that is the reason boron trifluoride and aluminum trichloride are the examples for neutral electrophiles. Because they are electron deficient, they are also considered as Lewis acids. Now what are nucleophiles? Nucleophiles are nothing but nucleo means nucleus, phile means love or affinity. That means nucleophiles are nothing but nucleus lovers. If you look at the atomic structure as mentioned earlier, the overall charge of the nucleus is positively charged because it is loaded with protons. Now if any species is having affinity towards the positively charged protons, it means that the species is electron rich. So that means nucleophiles are electron rich species which has the ability to donate electron pairs during the reactions. Now let us try to understand the types of nucleophiles. So there are 3 different types of nucleophiles are there. The first type are known as negatively charged nucleophiles. Because as I mentioned earlier, nucleophiles are the electron rich species because of the electron rich nature, so they attain negative charge. So that is why the first class of agents are negatively charged nucleophiles. Examples includes OH minus ion, which is known as hydroxide ion, Br minus ion, which is nothing but bromide ion, and Cn minus, which is nothing but the cyanide ion. These are the few examples for negatively charged nucleophiles. Now the second type of agents are known as neutral nucleophiles. That means charge-wise there is no formal charge for these nucleophiles, but because these molecules contains lone pair of electrons, that is n electrons in their structure, they are considered as neutral nucleophiles. The examples are ammonia and water. So in case of ammonia, it consists of nitrogen as central atom, which is bonded with 3 different hydrogens on 3 sides. But here the nitrogen consists of an excess electron pair, that means it consists of a lone pair of electrons. So due to the availability of this lone pair of electrons, it has the ability to donate this lone pair of electrons to any species which is deficient of electrons during the reactions. So as it is rich in electrons, even though there is no formal charge, it is considered as one of the neutral nucleophile. Same is in case of water. So here the central atom is oxygen, which is attached to hydrogens on 2 sides. So here oxygen consists of 2 lone pairs of electrons. So due to the availability of 2 lone pairs of electrons, it has the ability to donate these electron pair during the reactions, and that is how it is considered to be electron rich. So ammonia and water are the examples for the neutral nucleophiles. As they have ability to donate electrons, that means they are electron donors, they are also considered as Lewis bases. Now the third type of nucleophiles are the ones which are having the pi bonds. So these electrons which are available in the pi bonds are easily available to undergo in any kind of the reaction. So in case of alkenes, if you see carbon-carbon double bond, one bond is sigma bond, the other bond is pi bond. In case of alkynes also, one out of the 3 bonds, one is sigma bond and other 2 bonds are the pi bonds. Okay, so when compared with sigma bond electrons, the electrons which are present in pi bond are less loosely held between the carbon nuclei. That means they are easily available to undergo any type of reaction. So in that way, the carbon double bond present in alkenes and carbon carbon triple bond present in alkynes is considered to be nucleophilic in nature. So these are the third type of nucleophiles. So in summary, electrophiles are nothing but electron lovers, means they are electron deficient. So they are classified into three types: positively charged electrophiles, nothing but protons, bromonium ion and nitronium ion. Partially positively charged electrophiles are nothing but the carbonyl carbon in case of carbonyl compounds and carbon halogen bond in case of alkyl halides. And the third type of electrophiles are neutral electrophiles are nothing but boron trifluoride and aluminum trichloride. Now coming to nucleophiles, they are nucleus lovers. That means they are electron rich species. And coming to the types, they are classified into negatively charged nucleophiles, which are nothing but hydroxide ion, bromide ion and cyanide ion. And the second class of agents are neutral nucleophiles are nothing but ammonia and water. And the third type of nucleophiles are the carbon-carbon double bond in case of alkenes and carbon-carbon triple bond in case of alkynes are considered to be nucleophilic in nature. So now you know why electrophiles and nucleophiles are the real reaction warriors in organic chemistry. Here is your challenge for today. Pick one reaction from your syllabus and identify the electrophile and nucleophile in it. Post it in the comment section so that we can discuss it together. And hey, this is just the beginning. In my next video, I will show you how these warriors decide the fate of every organic battle. Hit the subscribe button and follow my channel so that you can study smarter, score higher and actually enjoy organic chemistry. Thanks for watching and stay tuned to my next video.